So let's review for AP Physics 1. This is mostly just going to be me talking. I might draw a few sketches, but so the way it's going to work, like for problems 1 through 5, I'm going to give you a situation. And basically what I do is I give you data. And using that data, you have to figure out how fast an object is moving, what its displacement is. So it's a constant velocity. This is unit 1. This is all about unit 1, which was constant velocity, right? And we took the position as a function of time data. We graphed it. From that graph, you can, if you look at the slope, that gives you velocity. So make sure you understand that the slope of that is velocity. And then you can figure out what displacement is, right? What is displacement, right? It's how much it changed its velocity, right? It's x final minus x initial. And so I ask you for displacements. And then I ask you for like the equation of the line. If you graph it, it makes a line. You don't have to graph it. If you want to make a quick sketch, you can. But I ask you for the equation of the line, and you have to figure out what that is. So with that one little problem, I have 5 multiple choice questions about it. And some of them are really basic, easy stuff. Don't worry. If something seems too easy to be true, I'm not trying to trick you. There's no trick questions, okay, on it. But you should, unit 1, constant velocity, and so on. Now 6 through 9 is constant acceleration. And this is where you'll need to use the kinematic equations for constant acceleration. I give you an object that's moving at a certain speed, constant speed, then it speeds up or it slows down or something like that. What is the displacement? What is the acceleration? So I give you a certain situation, you're going to have to know how to handle it. So review some of those. Also, I give you 4 kinematic stacks. You're going to have to choose which kinematic stack accurately describes what's happening in the problem. So it's a very straightforward problem, but you do need to know how to use the kinematic equations, or how to use it graphically. And again, if you want to graph it, you can. You're going to be able to use scratch paper. I don't want you writing on my tests. But you can have scratch paper and sketch things out, and that'll help. Problems 10 and 11. Oh, there goes my pencil. 10 and 11. Let's see. These are, this is free fall. Basically, I take a rock and drop it off a tall building. Okay. How much time does it take before it hits the ground? Or what if I give you the time? How tall is that building? You should know what the acceleration of gravity is, right? So it's just using the kinematic equations and figuring out what the stuff is going on with free fall. (12 through 14). Thank you. Is vector addition. We did that. Zoom out a little bit. Okay, vector addition. I give you 2 vector and polar coordinates. What do you got to do? If you're going to add them together, you need to change them to rectangular coordinates, add them together, and then you can convert them back to polar. So, the reason why there's 12, 13, 4, there's 3 problems there is I'll ask you, what is, what are these two vectors in rectangular coordinates? And I give you a bunch of choices. You have to, so, and then, so. And then problems 15 and 16. There's only two of them. Newton's laws. Newton's 3 laws. Make sure you know qualitatively what those laws mean. The first law, second law, third law. Especially the third law, the interaction, force on one object. There must be an equal and opposite force on another object somewhere in the universe. Problem 17 through 21 is a friction problem. Basically kinetic friction. An object sliding to a stop. You have to figure out what the force of friction is. You're going to, very similar to that take-home test, part C, that nobody got. And but something sliding to a stop. I'm going to ask you a bunch of questions about that. I might say, what is the normal force in this problem? So calculate what the normal force is. Or it could be as simple as, I give you the mass of the crate, and I say, what is the weight? Okay, do you know to multiply the mass by g to get the weight? They're that easy, some of them. I mean, they're really, really quite straightforward. I basically take a modest problem, very modest, and break it up into 4 or 5 little questions. So make sure you understand the definition, how do you find the coefficient of friction, and so on. And then 22 and 23. That's a net force problem. I'll give you an object with multiple forces on it. I want to know what's the net force, what's the acceleration, or what's the mass. Basically, you have figure out what the net force is, then use the net force equals mass times acceleration to solve the problem. 24 through 26. I give you an object. I give you a free body diagram. I give you the free body diagram. Oh, I need you to say, what's the net force in the x direction? What's the net force in the y direction? What's the overall acceleration of the object? So that's an FBD problem. 27 through 30 is a projectile motion problem. Basically, it's a pretty easy problem. You're just kicking a stone horizontally off the top of a cliff. And you want to know, how far from the base of the cliff does it fall? What is the final velocity? How much time is it in the air? How tall is the cliff? I mean, I'll give you enough information so you can figure all that out. Okay. Well, thank you. And, okay, yeah. Let's see, what else? Oops. And then 31 through 35. What is this about? Oh, this is a circular motion problem. And basically, you've got a car moving in a circle. What's the maximum speed? Or given a maximum speed, what's the coefficient of static friction? That sort of thing. It's be able to figure out what the period is. Know those. It's really a basic circular motion problem involving friction. So study that problem. And then 36 through 40 is is Newton's law of gravity. Basically, I'm going to give you a satellite in space. You have to figure out what is its orbital velocity, what is its height above the Earth's surface, what is the period of the orbit, all things like that. What is the acceleration of gravity at that point in space? So real basic stuff. I was going to give a multiple or a free response question part of it, but I'm looking at this test and I want to make sure that you guys finish it in the time given. So I think I'm just going to keep it to these 40 questions. These are the real basic problems, but it's quite a lot, So make sure your equation list is up to date, and you understand all the equations on it, and you understand graphing and slope and area underneath the graph and all what all that kind of stuff means. So that will be the final. Any questions? Okay. That is all.